I'm going to quick jot those down for us. Okay, do you see how this is separated by subtraction? So how can we condense it? What operation? Division. So I could rewrite this as log base 3 of 5 over x. Okay, the idea here is this. Do I have a single logarithm on both sides? Yes. Does it have the same base? Yes. Would you agree with me, just common sense here, if these are both log base 3, wouldn't what I have, I've covered some things up, would those two things have to be true to make sure that, okay, so all I'm going to do, as long as I can do that, is I'm going to drop the logarithm out. Some teachers will also say you could write 3 to the log base 3 of 2. Like it, and cancel out the 3 to the log base 3. But I'm just going to use the idea, common sense, log same base, we're going to solve these. The only thing we have to be careful of is the logarithm has a restricted domain. It can't be less than 0, less than or equal to 0. So we just need to make sure we don't get anything less than or equal to 0. All right, how would I solve that? What would I do first? Multiply by x. Now what? Divide by 2. The answer is 5/2. Okay, so this is how we would use logarithms or properties of logarithms to make something that looks a little bit more complex a little bit easier. All right, let's try question 13. If this is addition right here, how can I rewrite it as a single logarithm? Multiplication. Also, we have this 3 in front, right? Can't we put that back there? Okay, so I'm going to condense this. This would be log base 5 of 2 cubed times x equals log base 5 of 24 plus 2x. Notice I am not doing anything on the other side. There's no property I can use here because it's already a single logarithm. Okay, do we all agree 2 cubed is 8? Do you also both see how these are both log base 5? What was the resulting equation I could solve them? Would you solve that for me? And once again, we just want to double check that that would make these greater than 0, so we don't get an extraneous answer. Some of them don't have answers. So, okay, so that's really why we learn log properties. Okay, we're going to really use this strategy more so tomorrow than what we do today. Today is probably the most famous, or the thing hopefully you remember the most about solving logarithms, or solving using logarithms. We are going to use them to simplify or bring an x down. Okay guys, so today when I'm solving these, today when I'm solving these, before we try to use our last property, and our last property is this one. When you have the logarithm of any base, and then you have some number to an exponent, that process drops that exponent down to the front. So if I had an x in my exponent, what I'm going to do is I'm going to use that property to essentially call bringing the x down. Okay. So what I have to do is, though, I have to remember my properties of equation solving. If you do something to one side, you finish it for me. You got to do the same thing to the other side. Okay. And that same thing goes if you're going to take the logarithm of one side, you need to take the logarithm of the other side. So as long as we do that, we're good. The other thing is you do not want to do this process until this guy is alone. That guy is the base of my exponent, okay? All right, so look, we're only doing one example today. I know. It just has 6 parts. Well, we're not doing all 6. So example 1, part A. Do you guys see that the E is already isolated? Okay, so what we're going to go ahead and do is we're going to take the logarithm of both sides, because that x minus 2 is what I'm trying to figure out, and I don't know what it is. I can't figure it out if it's in an exponent. Now, sometimes you can use log, common log. Sometimes you can use ln, natural log. And I'm going to tell you that whenever you have a base with e, you want to use natural log because it's going to save you some work. And I think we all want to save ourselves some work. All right, so step 1, we're going to take the natural log as long as I do it to the left side, but you have to do it to the right side because it's an equation. So squeeze it in there. We're going to take the natural log of e to the x minus 2, but also the natural log of 19. My L's are cursive L's, sorry. You can make yours a lowercase l. So what is going to happen here? The x minus 2 is going to come to the front. So I have x minus 2 times the natural log of e. And on the other side, I have equals the natural log of 19. Now, you should know the natural log of e. That's why this makes this step shorter. Anyone know? It's 1. The natural log of e is like base e, and it's e to the first power. If you don't believe me, you can type in the natural log of e on your calculator, and it's still going to tell you it's 1. That's why that makes this process easier, because when I multiply by 1, do I need to do anything with it? No, I don't. So like the reason why, just a reminder here, is natural log of e is 1. You're going to want to keep that in mind today. All right, this cancels then. So to figure out this question, wouldn't I need to then, I have x minus 2 equals natural log of 19, wouldn't I need to add 2 to both sides? Okay, it's going to be an approximate. Let's figure out the natural log of 19. Make sure you close your parentheses after 19. And then plus 2. 4.944 is what x is approximately. If you wanted to check your answer, just going back to the original, I am going to do e to the answer minus 2, and I better get 19. And I do. Okay. Any questions on that so far? Let's hop over to B. Okay, so in order to take, we see again we have that x in the exponent. In order to get that down, I am going to have to take a logarithm, but I need to do some work here. Because is the base isolated in this? What's the base? It's not helpful to know that. 2. We need to get this 2 to the 3x. We got to get that part by itself. Okay, I need to get it isolated. So I think the first thing I'm going to do here is don't kill any cats. Please don't say 3 minus 5 is negative 2. You can't do that because this doesn't have a 2 to the 3x behind it. What you can do is move the 3. We're going to subtract both sides by 3. Now I have negative 5 times 2 to the 3x equals negative 17. Base is still not isolated. Okay, you now have to divide off our negative 5. So now I have 2 to the 3x equals, and then negative 17 over negative 5 would be positive, and it is a nice decimal, so let's go ahead and write it as a decimal. What do we got? 3.4. Okay, now I can bring the x down. At this point, it's not a base e, so you could use common log or natural log. I just actually tend to, on this section, always use natural log, because then I don't have to make a choice, and then if I happen to have a natural log of e, then it makes my life easier. So I'm going to take the natural log of both sides. That brings my 3x to the front. So I have 3x times the natural log of 2 equals the natural log of 3.4. What am I going to have to do to get the x alone? You're going to have to do two things. You're going to have to divide by a 3 and divide by a natural log of 2. Okay, so also you want to be real careful when you divide by 2 things on your calculator. I'll show you in a second. All right, so in order to figure out what x is, I'm going to take the natural log of 3.4 divided by 3 natural log of 2. You can either do it in 2 separate steps, or you can use parentheses around the entire bottom. If you don't use parentheses, your calculator is going to multiply the last thing rather than divide it. So you want to be careful of that. All right, so here we go. Natural log of 3.4 divided by, I'm going to put it in parentheses, 3 natural log of 2. Would you confirm when you do this, you also get 0.589-ish? Okay. Good? All right. Then the last example we'll do together, we are going to so bringing exponent down. What if you just have a single logarithm? We actually already have done this, so that's why I'm not going to spend a lot of time on this. One logarithm, rewrite in exponential form. What's the base of the log? 2. What's on the other side? 4. 2 to the 4th equals x. That's all we're doing in this case. And then you can figure out that last expression, 2 to the 4th is 16, right? So 16 equals x.